Once again, I welcome viewers and subscribers. My today's question is a pure inductor, 25 millihenries, is connected to a source of 220 volts AC. Find the inductive reactance and RMS current in the circuit if the frequency of the source is 50 hertz. Let us understand what happens when an inductor is connected to AC source. Inductor is a huge number of copper turns which is in the form of tube like solenoid. When such a conductor is or a coil is connected to the AC source of E0 sin omega t, what happens? Which opposes the flow of charge or flow of current. So then, according to the previous knowledge, the induced EMF is produced minus L di by dt. L is what? Inductance. Di is current. Dt. Then when you solve this, it's a mathematical knowledge. Submitting E sin omega t, which is applied, and I L di by dt, then d I will be this much. By integrating, you will be going to get this. So what you are going to observe is I equal to I0 sin omega t minus 5 by 2. So these are all quantities, usual meaning. Omega is angular frequency, t is time, and I0 is peak current, I is the instantaneous current. Now, what is the formula? XL is equal to omega L. That is opposing to EMF. That is in inductive reactance. Its units is ohm. And you can see here animation figure how that output, how that EMF will produce in the inductor. This is input one and output one. Both together, when you see, there is input one is blue color and the red one is the current which is producing in the inductor, or EMF is producing in the inductor. Once again, you see here, this is actually the what is happening. Now in the question, what we are asking you to find out what is inductive reactance and also current. Current using Ohm's law we can find out easily. Let's see. This is my YouTube channel, my mail ID. I am providing 1000 MCQ questions. Just started. I request you, all of you, whomever is see, view it number of times, understand my concept, and also subscribe. Don't forget to subscribe. View it and subscribe. Let's start that same thing which I just now explained you. So here is the question. The question is given over here: a pure inductor of 25 millihenry is connected to a source of 220 volts. Find the inductive reactance. Just now I told you what is inductive reactance. Inductive reactance is XL. Actually, it is. Let's solve. What is the formula is required for calculating inductive reactance? Inductive reactance is XL. What is that? The symbol XL. XL is equal to omega L. Omega is angular frequency. Angular frequency is 2 pi by T. That can be written as 2 pi nu. 1 by T is frequency and L. So T is not given, so we converted into frequency. So once this formula you know, then we can just submit it. What are the submission you have to do? 2 into 3.14 into frequency is given here how much? 50 hertz, right? And then inductance is how much? Inductance of the inductor is given 25 millihenries. So 25 millihenries, how to write? 25 you write into milli. Milli means 10 to the power minus 3. So then after calculating you will get here 7.85 ohms, because you know that XL is which oppose the AC source. So anything is opposing to the current, then we call it as reactance or resistance or capacitive reactance, like that. In AC, generally we'll see XL is inductive reactance, and in capacitor it is capacitive reactance. So like that you should remember. Then next question, what is there? RMS current. RMS current, how to find out? So I is equal to the RMS source, which is using Ohm's law, that is RMS voltage divided by the resistance. What resistance here? The resistance is inductive reactance. So V is how much is given here? This is 220. 220 you write volts divided by how much you calculated XL just now, 7.85. 7.85, when you divide it, you will get 28 amperes. So 28 amperes of the current will generate in the inductor. This is what actually, if you like my content, please subscribe. Thanks. Thank you.